Hey guys, and welcome back. My name's MrCaproni, and this is your AP Statistics. So today we're going to be looking at conditional probability. Now this is a continuation of our contingency table discussion that we had in the last video. But today we're going to dive a bit deeper and look at the different conditional probabilities, what that means, and how we find them. Then we're going to go ahead and show how we can use different types of charts and graphs to model that in a way that's much more visual and easier to understand and see in terms of the big picture. So with that said, remember, if you learned something new today, go ahead and hit that like button. And if you want to keep getting videos like this, go ahead and hit subscribe. With that said, let's dive right in, and thanks for joining me for AP Statistics. As a quick reminder, last time we were covering the Titanic sinking and kind of broke down all the passengers on there by either if they lived or died and whether or not they were in first class, second class, third class, or crew. Now, as you see here, we see that 711 of the 2,201 people were alive after all was said and done, while 1,490 were dead. Now, when we're looking through the columns, that's the split up by what class they were. So, for example, the 285 out of 2,201 people were in the second class of people. Now, with that said, at the end of the video last time, we broke these down into marginal distributions, which were not very hard. We basically took each of the totals I just mentioned and divided them by the total amount of people. That way, we were able to see what percent of all the people fell in each class and what percent of all of the people either lived or died. Now we're moving into conditional distributions. Now here's the difference. A conditional distribution doesn't consider all of the people that were on the Titanic. It looks at a specific variable and picks one of the options. Then it breaks that option down according to whatever our second variable was. In this case, we're going to look at the conditional probabilities of survival, being alive, based off of what class you were. So when I look at the grand total of people we are looking at right now, we are looking at the total amount of people that were alive at the end of this. So we're going to break down into what percent of the alive individuals were first class, second class, third class, and crew. Across the bottom, you'll notice that there are percents for each one of these columns. Now that percent is simply taking the total number of alive individuals that fell into that class and dividing it by the total number of people that were alive. So for example, this 16.6 is the percent of all of the people that lived that were second class. So again, I could reword that by saying 16.6% of the people alive were second class ticket holders. Now, in this next chart, we're going to see another conditional distribution breakdown, but this time we're going to be looking at all of the people that died, and we're going to break them still by their class. I know it says perished, but I'm not that politically correct. They died, all right? So when we're looking here, notice that, like, for example, the crew is 45% about of all of the dead people. Now, here's the question, though. When you don't see the big picture, numbers can be a little confusing. Because what if most of the people on the boat were indeed the crew? Well, then, of course, the highest percent of the dead people would also be the crew. Because if you started with more crew people, then if you look at all the people that died, they'll probably still be mainly crew people. So when you're looking at conditional distributions, it's better to see the big picture where you're looking at several conditional distributions at the same time. In this case, we would want to compare the percent of the people that were alive to the people that were dead. For example, if I went back and looked back at the alive data and found out that 10% of all the people that were alive were crew members, and now we're looking at the dead individuals and find out that 45% of the dead were crew members, we should be concerned. Why would we be concerned? Because that would imply that you had a higher chance of death if you were a crew member than if you were one of the other classes. Why is this? Well, if they were the same, both of those percents should be the same. Because let's say, I don't know, 30% of all of the people on the Titanic were crew members. Well, then in that case, 30% of all the people that were alive should be crew members, and 30% of all the people that were dead should be crew members. When we have a big split, when it would be like 10 and 45, that's where we're concerned, because that means that it did play a role in whether you died or not. So maybe buying a more expensive ticket was also your ticket to staying alive. This is where side-by-side charts come in handy, because what they allow us to do is see the big picture. So when I'm looking at these pie charts, in order for me to believe that your type of ticket did not play a role in if you lived or died, the pie chart should look the same. So anytime we don't see that, it's area for concern. And then maybe that's what we'll spend our time looking more into to see why that was the case. So for example here, you can see that out of all of our crew members, this pie chart has a much smaller percent of crew members than this one does over there, which would imply that the type of ticket you bought did play a difference. And in fact, you can even see that there are more dead third-class individuals as well as there were alive. So this shows us that it's not just crew members. It truly means that the more expensive your ticket was, the higher your chance of survival. As you can see here, for the people that were alive, a large chunk of them were first class, whereas out of the people that were dead, a very small sliver were first class. So these people literally bought themselves a ticket to survival. This idea that one variable plays a role in the other variable is a very important concept that we're actually going to explore all year long in this class. What is that concept? It is independent versus dependent. Independent would mean that one variable had no effect on the other one. So it didn't matter what class you were, the same percent of people were alive and dead of each class. Now, dependent would be the opposite. That means that based off your ticket, it did make a difference on if you were going to be alive or dead. We call that dependent, as in your survival chance was dependent on what ticket you purchased. But what if you're like, hey, Mr. Caproni, I hate pie charts. I can't read them. I'm terrible at them. I got some good news for you, because instead you could use a segmented bar chart. Now let's go ahead and take a look at what this baby is. Now it's not used as often as pie charts at younger levels, but once you get advanced in statistics, it can be a very helpful tool because sometimes it's a little bit more clear. So what is a segmented bar chart? It's the exact same as a pie chart. It splits all of your data into chunks based off of what percent of the whole they fulfilled. So as you usually would see a circle with a certain chunk out of it to represent a part of the whole, this sees it as a rectangle and kind of cuts out the area that would be equivalent of that percent of the rectangle. So whereas this might be actually a more accurate one would probably be around like right here. If this were like 30% of your pie chart, 30% on a segmented bar chart literally starts at 0 and goes up to 30%. Then, say for example, my next one, it looks like here it went from 30 to 55, would mean that that percent would be the difference between those two. So 30 to 40 is 10, another 10 for 20, about 25% were third class. So this is the exact same thing as a pie chart. It just kind of puts it as a rectangle instead. It can be really helpful because it's a lot easier to see exact percents on here than it would be guessing on a pie chart. It also allows us to see the difference between certain areas a lot more clear. I can see not only that the crew members were a much larger percent of the dead than the alive, but I can actually see that it was about a 15% difference by going from 30 to 45. So at the end of the day, pie charts and segmented bar charts are really just both visuals to help us show people if things are independent or dependent, which is a super important concept that we are covering in this class. The ability to show if one variable affects another in life is something that a lot of people desire to know. So in the comments below, why don't you let me know? Do you like the old school side-by-side pie chart better, or do you like this new segmented bar chart? Both are visuals, both are valid, but which one do you like better? Leave a comment and I'll let you know which side I fell on. With that said, thanks for joining me today, guys. We went through conditional probabilities, which was just finding the percent breakdown of each variable based off the other variable. And then we took that data and presented it in a visual way, either using a side-by-side pie chart or segmented bar charts. Again, my name's MrCaproni, and this is AP Statistics.